Okay, there's some new vocabulary in this section. So we have talked about sequence, so sequence of pattern. So you can have a finite sequence. So a finite sequence is a sequence that stops. So an example would be 6, 9, 12, 15. Versus an infinite sequence is a sequence that goes on forever. And it's either denoted because it reads that it's an infinite sequence, or you could have 6, 6, 9, 12, 15, dot, dot, dot. That means the pattern keeps going on. So we have a finite sequence and an infinite sequence, and we also have a finite series. So a finite series, the new definition is a series, is to sum a sequence. So you're adding up all of the terms of the sequences. So the finite series of this would be 6 plus 9 plus 12 plus 15. And a finite series, unless there's too many terms, is easy enough just to add them up. So the sum of 6 plus 9 plus 12 plus 15 is, this is 15 and 15 is 30 is 42. So the sum of this finite, or the finite series, if I evaluate this, it's 42. Whereas an infinite series is adding up 6 plus 9 plus 12 plus 15 plus dot, dot, dot. So an arithmetic infinite series, there's not going to be a final answer. So number one, use a finite sequence. Write the related series. So if this is a sequence, to write the series, it's going to be 5 plus 9 plus 13 plus 17 plus 21 plus 25 plus 29. This is to write the related series. So to evaluate the series means that you're just going to add these up. So if I add these up, I'm going to use the commutative property and put these two together and write 30. These two together, and this is 50. This adds up with 75. So 30 plus 75 is 105. Plus 14, I got 119. So to evaluate the series means that you need to add them up. Okay, 2. A staircase uses same size cement blocks arranged 4 across as shown. Find the total number of blocks in the staircase. So I can count, so this bottom layer right here is a 4 by 5. So this is 20 plus, so I did that row. This layer is a 4 by 4, so that's 16 plus this layer is 3 by 4, so that's 12 plus this layer is 2 by 4, so that's 8 plus 1 by 4 is 4. So the total number of blocks is 12 plus 8 is 20. This is 20, so that's 40 plus 20 is 60. So there's 60 blocks. So find the 10th term of the sequence. So I could just find the 10th term by doing 20 or 4. Keep my pattern going the other way. 8, 12, 16, 20. It's not too much to do 10. I could also use the arithmetic sequence explicit formula, but I'm just going to keep going. So 24, 28, 32, 36, 2, 3, 4, 5, 6, 7, 8, 9, 40. And then find the value of the series to the 10th term. So remember, series means add up the sequence. So I'm going to add up 4 plus 8 plus 12. So I'm going to add these up here. 4 plus 8 plus 12 plus 20 plus 24 plus 28 plus 32. Now this is a lot to write out, so here's one way that you could write it out more efficiently. You could write 4 plus 8 plus 12 dot dot dot, stop at plus 40. So this, because I added this in a plus, so if I put the ellipsis, this is called an ellipsis, and then I have a plus 40, it means that actually it stops at 40. So this pattern keeps going on. So I'm going to add these up, and I get 220 cement blocks. Okay, then for 3 and 4 down here, write the related series for each finite sequence. So write the related series would mean, and sum them up. So it's going to be 0.3 plus 0.6 plus 0.9 plus 1.2 plus 1.5 plus 1.8 plus 2.1 plus 2.4 plus 2.7 plus 3.0. So to evaluate the series means you're just going to add these up. And I get 16.5. And then number 4, write the related series. So if I write the related series, I have 100 plus 125. So that means that the common difference is 25 plus 150. And I'm going to keep it up all the way until I get to 225. And then it reads, evaluate the series. So it means I have to evaluate it, I have to add them up. And I get 975. So make sure that you know the difference between the directions. Write the related series, evaluate the series.